Hi guys, Lever here from Bright Young Brains. In this video, we are going to go through a somewhat extended or detailed example of how sigma notation works. So, we're all used to being able to easily answer sigma notation questions that just have a sigma expression and they just maybe say evaluate. However, you do get instances where you'll have a sigma expression, right? Where they'll give you the general term, they'll give you where you should start, they'll give you where you should end, but then if they want to be funky, they'll maybe even give you what your expression should add up to, or rather what you should get if you add up everything. So in a situation like like that, it means that within these three blocks, they'll sometimes leave something out, you see. So what I mean is, if they, for example, give us x here, xn plus 1, right? And then this is n is equal to 3, and this is 10. In a situation like this, right, here they can easily say solve for x. You see, if they ask us to solve for x here, we just have to remember the basics of sigma notation. Sigma notation basically tells us that we need to know that this is the general term. We need to know that this is where you start in terms of the numbers that you add up. We need to know that this is where you end. And we need to know that this is what our series is supposed to add up to. So if you're to solve for x here, you would need to reverse engineer the question. And this is what I mean. You would firstly need to identify what kind of a sequence this is. You see what kind of a series this is. And the key pointer here is that n is not an exponent, so the series is arithmetic. As long as the series is arithmetic, it means that we need to think of this Sn formula. So us thinking of this Sn formula, the idea is we would need to then keep in mind that firstly, if our expression here is equal to 216, it means that Sn here is the one that's equal to 216. So we have Sn, and remember, if they're going to be asking us to solve for x, we still look at everything as though we are dealing with a normal sigma notation question. You see, Sn we have a value for. Now, as you will be putting in values into this formula, x will be there somewhere, and then you'll be able to solve for x. So firstly, n, we said, oh yeah, let me use a different variable for this question so that it doesn't get confusing. It's just a placeholder. So here we're saying, firstly, your value of n, we said it is always equal to the ending minus the start, and then you always plus 1. So in this situation, n is 8. You see, our value of a, we said, it is always what you get. A is what you get when you put this value into your formula. You see, that's what a is. A is what you get when you put this number into your general term. So our value of a here is just x times 3 plus 1, which is just 3x plus 1. You know, that's what a is. And that's okay, because at least if you put 3x plus 1 here, you at least have x in your expression. So that's how you're going to eventually solve for x. Our value of d is quite interesting now, because it looks like d also is going to have x in it some way, somehow. So d, we know you can either say t3 minus t2 or t5 minus t4, it's up to you. So in this situation, t3 would be if you put a 3 there, t2 would be if you put a 2 there. So t3, for lack of a better word, will just be x with a 3 there, and then t2 will just be x with a 2 there, like that. You see, we put a 3 there first, we put a 2 afterwards. If you simplify this expression, I mean, you're going to have 3x plus 1 and then here you're gonna have negative 2x and then negative 1. If you simplify this, you're gonna have d as x. So our value of d is equal to x. So we have a value for d, we have a value for a, we have a value for n, we have a value for Sn. If you put all that into your formula, this is what you get. Put 216 there. There you go. Solving for x here is quite straightforward now, because if you simplify this, this is what you have so far. We have like terms in here. There you go. And if our calculations are correct, if you saw the previous tutorial, if our calculations are correct, our value of x should be a 4. So let's carry on and see. If you multiply the 4 inside here, solving for x here, the 4 is going to go to the other side. So you're going to have 212. What's that what? Yeah, I feel like I made a mistake somewhere, because this does not want to add up. Maybe the previous question I made a mistake, which is a bit scary. Yeah, it's quite scary. But let's see. Divide this by 40. Divide this by 40. Let's check what that gives us. This does not look like it's going to give us a 40 or 4 rather. 5.3. So definitely made a mistake somewhere, and need to find where that mistake could have been. Negative 2x, negative 1. This is fine. This is fine. This is fine. 216 is fine. 4. 8. Yeah, there's the mistake. You see, I didn't multiply the 8 times 2. So this is supposed to be times by 2 here. See, times by 2 there. So let's fix that. So here, if you're gonna multiply the 2 inside, right, you're gonna have like 4, 6x plus 2 plus 7x. And then 6 plus 7 is 13. And then solving for x here, firstly, I think we can multiply the 4 inside, or we can divide by 4. I say let's maybe divide by 4. And then if the 2 goes to the other side, you can have 52. And then if you divide both sides by 13, our value of x is the 4. There we go. So if you make mistakes, you can always just, backtrack your steps and you should be fine. So this is another angle of how sigma notation questions are asked. You see, the methods stay the same. What you do for these kinds of questions, it's all the same. You see, so whether you have sigma expressions that are mixed up with other ones, whether you have multiple of them and you have equal to signs and all that, just remember that every sigma notation expression represents an Sn formula. You just have to know which Sn formula you're dealing with. Is it geometric? Is it arithmetic? Or is it sum to infinity? You see, so that's all there is to it. You see, this question would have not been any different if it was geometric. If it was a geometric series that we're dealing with, our steps would have been just the same. We would have chosen a specific formula, which will be the Sn formula for a geometric series, and then we would have just worked with that. If our expression had an infinity symbol, we were just going to use sum to infinity. We were just going to use sum to infinity to work out that question. So that's that for this sigma notation example. For more tutorials like this, do not forget to subscribe to the channel, and I will catch you in the next video. Peace.